DataStax is the company behind the massively scalable, highly available, cloud-native NoSQL data platform built on Apache Cassandra. DataStax gives users and enterprises the freedom to run data in any cloud at global scale with zero downtime and zero lock-in. Well, hello everyone. Here we are for a pancake breakfast, the virtual kind. Hey, Sam. Sam, can you pass the syrup for me, please?
I got your syrup right here, Alex.
All right. Thank you, Sam. Put some syrup on my pancakes. These are virtual pancakes, but these ones are real. You can tell that we got the virtual thing going on. Let me try a pancake quickly, guys. You know, as Sam said, this is Portland, so these are vegan and gluten-free.
I'm expecting that they're very local. Are they local?
They're at his house.
Oh, yeah. Talk amongst yourselves.
Did you know the name of the farmer who grew the vegan wheat?
Yeah, we went and visited him at his farm. We lived there for a year before we could actually take it home. But outside of Portlandia jokes, we are here for a virtual pancake breakfast. And our topic today is a fun one. We're going to be talking about how data is everywhere now and how that poses a whole new set of challenges to users. And in particular, it makes us really think about data planes. And data planes have not been discussed as much in Kubernetes circles. Primarily, I do believe, because the control planes need to be figured out first. Now, I'm sure there's lots of opinions on this matter, but I wanted to just explore how we think about databases such as Cassandra and how you're engineering Cassandra in this age of the data plane. Now, DataStax is our sponsor, so thank you very much to the DataStax team. Here we have Kathryn and Sam. Hi, Sam. Hi, Kathryn.
Hi.
Hey, Alex.
Kathryn Erickson is with DataStax. And Kathryn, maybe you can tell us a little bit about yourself.
Sure. I've been at DataStax for 5.5 years. I work with Sam on the strategy team and work on product and ecosystem strategy as well.
Excellent. And Sam, Ramji is an old friend of mine. He's actually stayed in this house here, and in exchange, he was kind enough to bring a nice few bottles of wine that we enjoyed during the OSCON days, which are no more, unfortunately. But Sam is Chief Strategy Officer at DataStax. Sam, it's great to have you here.
Alex, it's great to be here. And I look forward to being able to pay you a nice case of wine to stay on your couch again.
Excellent. Also joining us from Minneapolis is Aaron Ploetz. And Aaron is an engineer with Target. Hi, Aaron. How are you?
Hey, pretty good, Alex. How are you doing?
Excellent. Look forward to hearing from you. And Janakiram MSV is also here. Johnny, how are you?
Doing good, Alex. Great to be here.
Johnny is an analyst. He's a contributor to the new stack. He's also a certified Kubernetes user. And so he's quite knowledgeable about the issues we're going to be discussing today. Also joining us is Joab Jackson, managing editor at the new stack. Hey, Joab.
Hey.
Hey, good to have you here, Joab. And Joab will be taking questions that we have from the Twitterverse and other places. And so we will intermingle those questions as we proceed. So again, our topic today is about the whole discussion is about Cassandra and Kubernetes engineering the cloud native data plane. We're going to be talking about Kubernetes operators. We're going to be talking about how Cassandra is being transformed into an operator. We're seeing examples of that, and DataStax in particular has its own example. And we're also going to be discussing how we think about applications and how we think about the users in these times. And so I thought it might be really important to just start off immediately with discussions about the users. And we're in a different time, as I was saying, we're in this time of COVID-19. And I'm really curious how data management is for the users out there. What are they facing? Aaron, maybe you could provide some perspective about that.
I can tell you for sure that, the systems that I work with are, at least on the digital side, drastically, seeing drastically more traffic right now. I mean, that is for sure. And, every day we, my team and I, we wake up and, we go in and see what challenges are coming from that next, and maybe what we can do to, kind of help keep things, moving forward. It's, about a commitment to our guests and about making sure that, we can provide services and ultimately products that they need. But yes, our systems are absolutely seeing an unprecedented amount of load, and so far they're doing great.
Sam, it's like a wrinkle in time a little bit. It's almost a look into the future, isn't it? And does speak to the need for databases that are resilient and scalable.
Yeah, and Apache Cassandra has got over a decade of hard-won, battle-tested code improvement that shows that it can be a distributed database. And it's interesting to look into the future at the machine learning, right, and AI-driven future of applications. And you look at the kind of loads that those systems put on modern infrastructures, right? Just doing a training set on a set of static image data, you could be looking at sustained demand of many gigabytes a second, let alone image recognition overlaid with video, with audio, anything else that you might want to do, multidimensional data. So the demands on the system for raw throughput, time is the ability to scale as wide as you might scale a cloud infrastructure like Kubernetes, kind of does give us a little peek ahead of time, right? What's the old most excellent quote? The future's already here, it's just unevenly distributed. Thank you, Mr. Gibson.
It certainly is unevenly distributed now. Johnny, perhaps you could give us a little bit of background about Cassandra and Kubernetes, and maybe even provide a little perspective on a control plane. And we hear a lot about control planes, and that's really about the routing of the bits onto the network. And then with the data plane, we're talking about how the data really essentially flows through those routers. How is that perspective changing now? And what does it mean with Cassandra becoming an operator? Maybe you can help us define an operator, help us understand a little bit about Cassandra, and then we can get into the discussion about control planes and data planes.
Sure, Alex. So a few trends. First one, Cassandra has been around for over a decade, and it's one of the proven battle-tested distributed databases. A lot of customers use it for structured, unstructured data, and the unique ability of Cassandra is really scaling out. So that is one of the important differentiators for Cassandra. That's one. Second, in the last 5-6 years, we have seen the evolution of Kubernetes, and it has won the orchestration battle. Today, whether it is cloud or enterprise data center or any hosted environment, Kubernetes is becoming the new Linux. It's the new operating system to run extremely scalable workloads. That is the second important trend. The third important trend that we have noticed in the last couple of years is the emergence of multi-master, globally distributed databases. There has been a lot of innovation that has gone into it, whether it is Google's Cloud Spanner or Microsoft's Cosmos DB or Amazon's Aurora. There is something unique about these database offerings. They can actually run across the globe in an extremely distributed fashion and in an extremely consistent fashion. So that is the third trend. Now, the advantage we have today is the maturity of open source projects like Cassandra and Kubernetes are giving the ability to emulate some of the capabilities that these globally distributed databases are delivering from the, which are basically coming from the cloud providers. So a combination of Kubernetes and Cassandra enables customers to achieve what only the web scale and hyperscale providers are able to deliver, but with complete control and with complete open source capabilities. So that is exactly where Cassandra meets Kubernetes. A distributed database meets a distributed system. Both are meant to deliver extreme scale. Now, taking that to the next level, Kubernetes has been traditionally used for managing and orchestrating stateless workloads. It can really handle a lot of traffic and a lot of distributed scale-out architectures really well. But the challenge has always been, how do we run stateful workloads and get the same reliability and scale and the distributed abilities that stateless workloads deliver? And it's not been easy. There has been a lot of work and thought process that has gone into making Kubernetes the first class citizen in the stateful world, and we are still work in progress when it comes to that. But the good news is there have been some patterns and some best practices that have evolved. And one such pattern is the operator framework and the Kubernetes operator, which is trying to bring some of the traditional DBA, DevOps, and SRE tasks in a very automated, in a very efficient form to Kubernetes. So essentially, operator bridges the gap between a traditional workload like a Cassandra database and an extremely modern and scale out architecture of Kubernetes by automating some of the DBA tasks, backup, restore, recovery, maintaining uptime, and so on. So today, when we have Cassandra as an operator, what it really means to the ecosystem is the ability to use best of both. Best of a distributed proven database and the best of Kubernetes world, which will give you a lot of automation and a lot of scale out capabilities. So that's exactly how an operator bridges the gap between traditional, not so automatable workloads in an extremely scale out and automated universe of Kubernetes.
So Kathryn, I'm curious, what are you hearing from users, and how are they thinking about these new data planes, and with Cassandra in particular? What are the challenges they're facing, following up on what Aaron was talking about?
So we've always followed the new stack survey that comes out every year. And every year you see that there's the question, what do users want to automate after the scale of applications? And every year it's the database. And that's exactly what our users are telling us too. They want to eliminate management operations, but there's also a lot that Kubernetes affords them. They want to scale up in terms of CPU and DRAM versus just scaling out, which comes pretty natural with Cassandra. So it's about eliminating operations. It's about opening up new avenues for scale and really operating the database in the same environment where they're already running their applications.
And I wanted to go back to Sam, and what's your perspective about data planes now? You know, you've been a technologist for a long time, and you've seen the emergence of Cloud Foundry. You worked with Google. You've seen now at DataStax, you know, the evolution of Cassandra, which is a well-established database. And now we're working in the Kubernetes environment, and control planes have gotten much of the attention, and now data planes are starting to get more attention too. What's your perspective on this from a user perspective, from your own perspective as a technologist?
It's nice to have enough years under the belt that someone can call me old and not be upset about that. Being old beats the alternative. Yeah, so I've been in the software industry for about 25 years. 15 years ago, I was leading open source and Linux technology at Microsoft, of all places, and that's where I started to see the enormous scale opportunity for open source and Linux. We did some cloud demonstrations to leadership, all based on things like OpenNebula, AppScaler, a range of different open source technologies. We showed Hadoop running on top of Docker. It was pretty wild. Going to Apogee, I saw the opportunity to build a control plane for the open web, right? So the web was going dark, and you started seeing APIs were replacing, standard HTTP calls. So at Apogee, we built a control plane for API traffic, and we built it on top of Cassandra, because it turned out there was so much traffic. There was an enormous amount of data that we had to move very, very quickly just to manage what was happening in the API tier. I got a chance to lead the Cloud Foundry Foundation to see what applications we're doing with a cloud native architecture and how you could subtract the 12 factors described in 12factors.net. How do you take those stateful capabilities that are so difficult developers to get right, abstract them out, and put them on top of what was called BOSH. BOSH, B-O-S-H, it's part of Cloud Foundry. It's like Borg, but one better is the idea. If you increment R and the G in Borg, you end up with BOSH. That's a little known provenance for that name. Your ability to run a database in Cloud Foundry then was all about being able to automate, give lights out operation to your ability to scale a particular part of your data tier so that that service scaled independently of the application. That way you could put the right work in the right place. An operator who really understood the database was responsible for scaling that. And then the platform itself scaled the application. It was all beautiful, except you get to the point where you've blown past the limits of what you can algorithmically scale in the database. You need to shard the database, and you need to start splitting it up. So addressability became an issue. I then went to Google and led the Kubernetes business, where I got to work with some of the smartest, most capable computer scientists in the world and learned about Google Spanner. So when you look at why Google was able to build a modern AI and machine learning business, which is called Search, it's called Ads, it's called Gmail, it was because it had this Borg control plane and you had Spanner as your data plane. So the marriage of those two things made compute and data so universally addressable, so easy to access, that you could do just about anything that you could imagine. So now I think as we look at the next decade, we can say, well, from 2000 to 2010, global scale networking got solved in a scale out way. In 2010 to 2020, global scale compute got worked out, right, in a scale out way. And now from 2020 to 2030, delivering on what network providers have done, delivering on what Kubernetes has done, there's an opportunity to make data really easy, really manageable, and create a playground for apps of the future, which will include AI and ML apps.
So Aaron, I want to go back to you about your experiences with Cassandra, especially during these times. And what about these advancements? Are they coming to bear? And maybe what are some of the gaps that you're seeing? And what is it that Kubernetes and Cassandra can resolve?
Well, just to kind of touch on, some things that Sam said, I haven't been doing this 25 years, but pretty close. And I'm to the point too where I get called old all the time. And yeah, I remember the days when scaling out a cluster meant submitting like an acquisition request so that we could go buy a server from Dell or several servers from Dell, and having to, go and defend that decision and say, oh, no, we really need these, or we can't scale. That's it. And that was, when you're talking a large enterprise, large enterprises move at like a glaciatic scale. It's not nimble at all typically. And, using something like Kubernetes allows you to just say, oh, well, I need 2 more nodes. Okay, boom, boom, boom. And there you go. It's that agility, it's that ability to scale quickly. That's the big benefit there. As far as some of the gaps, I had a chance to work with Kubernetes a few years ago. Maybe before it it kind of hit a level of maturity that it's at now. There were some things like hey, we have a pod that goes away. How do we get it back with the same IP address? That's normally not something you'd care about if you're writing something that's like a REST service, But in Cassandra, you absolutely do care about replacing that IP address and knowing what it was before it went away. And likewise too, to Johnny's point about working with stateful sets, that's important now too, where it's like, hey, when that pod goes away, how do I make sure when I build up my new one that I've got that persistent storage there, that I can just hook that up and go? Because otherwise I have to restream all of my data back to that node again. So, it's the changing of the times, and there are some things that start out with good ideas and really aren't polished out, but eventually we get there.
Kathryn, before I go to Joab, I want to just say that is one striking sweater you have there.
Thank you. It's a little Pancake green screen shirt. I can add to what Aaron said. We often felt like we were late to the game with Kubernetes, but what we were doing is what Aaron's team was doing as a user and watching that maturity happen. And what we saw was this kind of battle cry from the Kubernetes community for stateful sets and for persistent volumes, letting that storage follow the pod when these moves and new pods are rolled out. Things that we are worried about, like transient IPs, with the emergence and the popularity of management sidecars, are things that we've had to worry about a lot less.
A lot less. So can you quantify that to any degree?
Sure. So when you add a Cassandra node, it looks for a seed and it says, I'm ready to join the cluster. Well, in Kubernetes, you're using DNS names. So what we do with the management sidecar is when we want to add a node, we just resolve the host name, the IP address of a seed, and just make sure that we're orchestrating these things to happen in the right order. So we're okay if the IP address has changed. We just do a quick check upon startup to make sure that we know that.
So who does the quick check? Is that the operator that does the quick check, or what is the quick check being executed by?
It's handled in the management sidecar, which is working in concert with the operator. So there's some things that the sidecar lets us do, such as orchestrating startup, rollout, scale out, and scale in of nodes. But there are other advantages that we found in the sidecar in that there are things that we do backup and repair that the community has other solutions for. And so by moving some of those management pieces into the sidecar, we can make room for all the community-based solutions that exist for these management operations.
So Johnny, what is, before I go to Joe, I keep putting him off Joe, but I want to follow up on this thread with Johnny about the usability here. And what have you found with this delineation? Because I find it interesting, this concept of how the sidecar container is being used. We're hearing a lot more about sidecar containers, in their use. I mean, for instance, Istio, the latest version of Istio talks a lot about using sidecars, and they actually have a daemon now that they're really focusing on. They call it Istio-D, as they call it. But I'm curious from your perspective, because you have a lot of experience here.
Sure, Alex. So sidecar is becoming a very important pattern for a lot of Kubernetes workloads. And it inherently takes advantage of the way Kubernetes pods are designed. So for all practical purposes, a Kubernetes pod is like a process. So having a sidecar is like attaching a sub-process that will continue running its own context, its own thread, while helping the parent process or the actual container do some administrative tasks and some housekeeping tasks. So in Istio, or for that matter, in a lot of service mesh architectures, sidecar will intercept the inbound and outbound traffic and will figure out if encryption is applied and what is the latency involved in making the outbound call, and is the outcome successful and can perform things like circuit breaking and retries and so on. So it basically acts as an agent that sits in between the recipient of the other side and the actual sender, which is the pod itself, and does the housekeeping and does the basic hygiene check, while the communication and while the background processing is going on. So a lot of Kubernetes workloads are taking advantage of this because it's very easy to package and deploy and scale. And in the context of Cassandra operator, a sidecar, as Kathryn mentioned, will coordinate with the operator and will make sure that it again brings the Cassandra stateful sets on par with rest of the Kubernetes definitions and Kubernetes standards, by making sure that the IP addresses are resolving, the DNS resolution is up to date, and does everything that Kubernetes world expects from a typical stateful workload, while bridging the gap with traditional Cassandra.
I'd like to go to Joab and see what questions we received from people on Twitter. I know there's some in particular that were pretty interesting that we'd love to get your insights about. Joab?
Yeah, we actually got a lot of operational questions. As you guys had mentioned, late last month, Cassandra released an operator a Kubernetes operator. And so a lot of people are like, well, how does it work? What's going on? What do I need to do? One of our questions came from Lena Hall, who's a director of engineering at Microsoft. She specializes in distributed data, and she was actually previously with Microsoft Research. She was very curious about the operator. The first question she had is, how much and what kind of knowledge and expertise does Cassandra expect teams who use the operator to have, both for Cassandra and for Kubernetes? I mean, how much work is it? Is it too difficult to work with or troubleshoot? What's your take on that?
So far, the feedback is great, but I think the point that Lena's getting at is that you want to reduce management operations, but you don't want to take on the complexity of learning an entirely new technology. But what we're really seeing is a standardization on Kubernetes. So it's bringing our game to the new playing field. For customers that aren't as familiar with Kubernetes, we're seeing a lot of deployments within the automated enterprise platforms, whether it's OpenShift, PKS, Tanzu with VMware, AKS, EKS. These are pretty straightforward ways for customers to get started with the operators.
Yeah, and as a user who actually tried the operator from DataStax, I found it to be extremely simple. Having deployed Cassandra in the traditional stateful technique, there was a lot of plumbing that had to be done. You need to know a lot of details, the nuts and bolts of running Cassandra as a stateful set. What I actually found with the DataStax operator is you push the operator and it does a lot of groundwork before you deploy the stateful workload, and then you just need to apply another YAML manifest, and in just a few minutes you have the 3-node Cassandra cluster up and running. All you need is Kubernetes and a storage layer. So once you have this, push the operator and take the help of operator to push a highly available stateful workload, and in about 5 minutes, depending on your bandwidth, you actually have a fully fledged Cassandra cluster up and running in Kubernetes. And it doesn't expect a lot of background or knowledge of the operator. In fact, it is designed to help you overcome all those gaps and limitations by focusing more on the workload instead of the operational aspect.
Sam, any thoughts on the question?
It's a question, and I love listening to the answers because it's all about lineage. When you look at the lineage and history of these technologies, right, Kubernetes started in someone's mind as Borg v1, in the mid-2000s, Borg v2, and when Eric Brewer and Craig McLuckie and the team all looked at what they were going to bring to bear on the next generation of cloud, they didn't want it to be exactly Borg. They wanted to borrow some of those concepts and then build something new that was simple. So all of that stuff was in flight, by 2014, 2015. And that's taken several years to mature. Cassandra didn't have the advantage of any of those layers of infrastructure to rely on. So the Cassandra project had to build its own thoughts on networking and configuration and distribution and connection and discovery. Now that all of these technologies have kind of caught up with each other, our ability to embrace the standard with Apache Cassandra working in a native way with Kubernetes should have exactly the effect that Kat and Johnny just described, which is simplification through standards, and then automation through isolating the knowledge that the Cassandra community has gathered over time into a program, right, into the management sidecar, into the operator itself. So our ability to give you an autonomously operating data plane that works natively within Kubernetes, it's all about bringing these two lineages together in ways that leverage the best of each.
I just want to add something here. So I've been actually talking to one of the largest hosting providers, and they want to offer NoSQL DB as a service on Kubernetes. And their goal is to meet the stability, reliability, security, and availability of a managed database like RDS. So with Kubernetes becoming the control plane and the de facto standard for infrastructure, they want to deliver database as a service, which will hide the complexity and the nuts and bolts of running a distributed database. So that's exactly where the operator comes in. One key takeaway from the operator for stateful workloads in Kubernetes is the ability to deliver DB as a service, almost bringing it on par with the cloud providers DB as a service like Amazon RDS or Google Cloud SQL or SQL Azure. So this is one mechanism to deliver that ability to enterprises, colo providers and hosting providers to completely offer a packaged NoSQL database as a service to an extent that they can even commit SLAs because they can actually rely on the operator and some of the abilities that Kubernetes plus the operator are promising.
Aaron, any thoughts on this question and what Johnny is talking about, and with Sam as well, and the kind of perspective on, from a user and how you think about these things?
Well, I think in terms of from the actual question, like what skills would you need to, be good at Cassandra or be good at Kubernetes? I think in this one, it's more about, being willing to learn and being willing to adapt to something new that's coming in. It's not uncommon for people who have experience with Cassandra or any other data store that you're trying to run in a stateful set on something like Kubernetes to come in and feel handcuffed because they can't go in admin and DBA the way that they're used to doing it. And it's another set of skills that you just kind of have to be patient with yourself and kind of take it as it comes. And then I had a thought on what Johnny was saying, and now it escaped me.
Well, he was talking about database as a service. Maybe that'll provide a little help. And then this hosted provider.
Database as a service. Yes, database as a service. That totally seems like the trendy thing to do lately. Every cloud provider has their own database as a service, and they if they don't have one, well, sometimes they go out and they grab one like Redis or Cassandra for that matter, and offer their best shot at it. And if you look at it, the ultimate goal is similar to what we're trying to do with things like Kubernetes. It's to abstract that data layer away from the developer. A friend of mine that I used to work with for years used to have this concept of what he called the midnight developer, where you want to be able to support somebody who's working hard on an app at midnight, and they want to be able to deploy to prod at the push of a button. And they don't want to have to engage a database team and then engage a data modeling team and then engage the infra team to get this all set up and get it orchestrated. No, they just want to hit a button and go. And tools like what we're seeing evolve today are definitely helping developers do that.
I think one of the fun things about Cassandra in that environment is that many databases have an absolute limit of vertical scale. So even if you're running it as a service, once you throw that on an AWS extra large or whatever your moral equivalent is, you're kind of out of room. And now you're going to need to partition the database, right? You're going to have to come up with a way to shard it, and then you're going to need to push that sharding logic back into the application layer. So as an application developer, for the benefit of just being able to keep my application running, which my users like, which I just need to succeed because the business wants to succeed, I have to do a 0 feature release where all I do is change the logic, make it through all the smoke tests, get it through deployment, get it through my blue-green deploys, make sure everything still works. So a whole application development cycle just to adjust the sharding logic. Marketing's not happy because I didn't create any new wow features. Support's not happy because I didn't resolve any of the tickets that they had in there. But just for being able to scale the back end, I've changed my application logic. So moving away from that into something that is more cloud native, more the way that Kubernetes thinks about the world, scale out and scale in, requires you to have a different point of view around the database. So to Aaron's point, you have to be patient with yourself and learn the tools and skills that you need to succeed in this world of infinite demand.
Joe.
Yeah, I had a question actually myself. With this infinite scalability, this combination of Kubernetes and Cassandra, what, and of course the easy deployment that Aaron mentioned, what sort of new workloads can this enable? What sort of, with this force multiplier, what can enterprises or startups do that would have been too difficult before?
I'll start with something super mundane and then pass it to people who are more technically competent to answer the question. Scale in is the secret strength of cloud native. We all talk about scale out. Can you grab more resources? Can you meet the spike in demand? But most importantly, the reason that Google works as well as it does to meet demand of applications like YouTube and Gmail all around the world is when that demand spike is over, the application lets go of the resources and now can be used by somebody else. So there are a lot of cases that we've run across where people would use a lot more Cassandra. They would take a lot more dependencies on Cassandra if they knew that they did not have to provision to peak. And so that idea that you can have a good citizen playing really well in a cloud native environment that uses resources to spike to meet the demand and then let go so that the whole infrastructure can sustain routine usage is super, super important. I'm sure Aaron and Kat and Johnny have more pointed insight.
And my favorite workload for Cassandra on Kubernetes is IoT, Edge, and AI. Cassandra is fantastic when it comes to unstructured data. So I can actually connect dozens of surveillance cameras and smart cameras to Cassandra and stream the live camera feed and store them as unstructured blobs. And later on, siphon that off to another data lake and train my convolutional neural network that does detection of objects or segmentation of objects. So Cassandra could be that front end for ingesting unstructured data coming from a variety of sources, whether you are capturing audio data from mics or video streams from cameras or sensor fusion, which is a combination of using sensor data coming from multiple IoT devices. All of that can seamlessly go into Cassandra and can become the input for large machine learning and AI models.
I love that answer. When folks move to Cassandra, they're often on a relational system and it's hit its limit in terms of scale or getting that application close to the user and global replication. So what we want to do now is take that further. Can you have edge clusters as 5G becomes more available that manage themselves, that are easy to deploy? There are so many definitions of cloud native, but what our customers are looking for is ubiquity of deployments, and this gives them exactly that.
We have another question from Lee Caswell. He's a VMware exec, and he is asking, will the operator continue to work for both open source Cassandra and the enterprise products?
Great question. The answer is yes. We released the operator, and it does work for Cassandra and for DataStax, but the next step is actually to work really closely with the community to provide a generalized solution for the Cassandra user base. Cassandra 4 is in its final stages of testing right now. That's where everyone's focus is. And after that, we'll work with the other community members like InstaCluster, Sky, Netflix, and others that have built cloud native management APIs and operators to really come to a generalized solution. What VMware is working towards is ubiquity across clouds with the Tanzu release. And it's important for our customers, they voiced this to us, that platform supports both the enterprise and open source offerings. So yes.
And strategically, our intent is for Cassandra to be awesome everywhere, right? Wherever Cassandra can receive some technology that's going to make it a more obvious, excellent choice for scale out applications, we want that to be something that happens. So when we look at ubiquity for an environment like Kubernetes, we want to make sure that we've got a great solution that you can get Apache Cassandra, cloud native, with a great operator, with a great management experience, automation built into a sidecar from anywhere for free to use in any environment. And so that's kind of the spirit of functional open source communities. And I think our intent as we offered the management sidecar and the operator into the world was that it would represent an informed opinion that was by no means an exclusive opinion, but was an invitation to collaborate with anybody else who cares about the same thing. So if you care about Kubernetes and Cassandra together, if you care about cloud native data, then we invite you to come and bring your ideas to the party And hopefully 6 months, 12 months from now, all these ideas will have merged and melded, and there will be a obvious common default Cassandra operator for Kubernetes that everybody will use. And the de facto expectation will be like, well, you've got your Kubernetes installed. Do you have Cassandra on it yet? So we'd like the answer to be yes.
Aaron, I'm curious in your perspective, what is it that you're looking for when you see Cassandra and Kubernetes together? I expect this is just logical that you'd want it to be working for both open source Cassandra and the enterprise products.
Yeah, Sam has a good point about making sure that it's you know, an ubiquitous experience, regardless of, you know, which version of Cassandra you're using, whether it's Apache or whether it's a licensed product. You know, I've worked with data stores in the past that they will have a you know, obviously they have their enterprise, you know, version of it, but then they also have what they call like a community version. However, though, they maintain a difference in feature set that obviously you don't get the good features unless you pay for it. And you know, when you're trying to grow a community and trying to really build a good grassroots base for your technology, just, you know, it's decisions like that that can leave a bad taste in people's mouths, and that's not what you want. So you definitely do want things that work in enterprise. You want to make sure they also work in that open source edition as well.
Joab, do we have one more question that we can ask here?
Oh, we certainly do. Lena Hall had asked, it's a personal question. I'm very curious myself. Did the Cassandra team, who helped to develop the operator, have primarily Cassandra experience or Kubernetes experience, or what were some of the challenges when developing the operator?
Sure. So it's actually a balance, and it's really been a journey. The operator that we've released is based on the operator that we use to manage our own cloud platform. We could have gone either way. Building the operator requires a deep understanding of distributed systems. The distributed system that we understand really well is Cassandra. The cloud platform engineers that we brought on have a deep understanding of distributed systems as they apply to cloud native platforms. There were decisions, do we write this in Go or in Java? And those were real battles that we worked through internally. The team that built this had a few rock star Cassandra experts and a number of Kubernetes experts as well.
Sam, from your experience in working on projects such as these, what is it that you find in teams that really build these strong communities? I know the community aspect of this is critical, and a lot of it is and historically has been reaching out to developers and and getting their input and their perspectives. I'm curious about your approach. What is it that you're looking to do here? Because this is a community project. This is a Cassandra project.
Yeah. So I think, curiosity and diversity are usually the two keys for making a successful open source project. People have got to be coming to the problem with genuine curiosity. How does this work? What is the structure? What makes it hard? How do we learn from each other? What could we do, right? It's got to be sort of curiosity in action rather than theory, because I think anybody can theory craft and imagine, edge cases which aren't provable. So the curiosity's got to be so strong that it drives you forward to test it. And then diversity was the thing that we found so crucial at Cloud Foundry, was the authentic interest in bringing in experiences, points of view from people who we hadn't talked to before, who didn't think like us, who didn't talk like us, who didn't look like us. And the richer and stronger that community got with people from, many countries, many experiences, many points of view, biological diversity, sociological diversity, that was what let us really build something that was a powerful, consistent, trustworthy, and expanding open source project. As I left Cloud Foundry, I was replaced by Abby Kearns. She became the CEO of the foundation and continued to bring this strongly minded, diverse orientation to the project, which mated with that curiosity to produce a really good discipline. And she just announced today that she's stepping down and making way for Chip Childers, who I had hired 5 years ago as the CTO for the foundation. He's now taking over as the executive director, CEO. So continuing to bring in that sense of diversity, a range of experience, and authentic curiosity. How's the world going to work? Those are the things that really bring us together as human beings. And at its core, open source communities are really about curious human beings doing the best that they can to understand a complicated technical environment.
Aaron, Johnny, and then I'd like to finish with Kathryn. Aaron first, maybe. What is it you're looking for from this project? And it's clear that the loads are just going to be tremendous for everybody out there who had traditionally, for instance, had lots of physical locations, and now everyone's moving online. We're hearing stories about this all the time now, about how companies, for instance, are looking to develop almost like static sites on the front end with microservices on the back end, so they can just be more closer to the workloads. And I'm just curious, what is it about this project that you want to see? What do you want to see it evolve to from what you're learning right now in these very real life scenarios?
Well, let's see here. Kind of the main thing is that if you look at a lot of Cassandra's strengths, it's got its abilities to be scaled out quickly. That's important, as well as its ability to handle geographically based workloads. I mean, to be quite honest, until Google Spanner came around, I don't think that there was anything else on the market that did that as well as Cassandra, and it still does it very, very well. But it's the ability to go ahead and define logical data centers that place your data right up next to your apps. I mean, that's key right there. I know that I've built clusters before that have spanned sometimes 6, sometimes 8 data center providers, and it's it gets a little tedious, but if that's what the business needs, that's what you need to do. And it really is all about, again, kind of like you mentioned there, Alex, about getting your application or your service close to your data. I mean, that's key.
What's going to be the challenge, Johnny? What is it that you're really looking to see from the Cassandra community?
Sure. So one thing that I really liked is I read this somewhere. I think DataStax announcement, meeting Kubernetes users where they are. So and that's what Aaron is also highlighting, bringing data to compute. It's not about moving the entire data center to where the data lake is. Instead, it's bringing data all the way down to compute and keeping it close to the processing. So the forward-looking view is we are actually in a very interesting twilight zone, as I would like to call, is the overlap between stateful workloads and the strength of Kubernetes orchestration. So eventually, Kubernetes is going to become the universal control plane. It is not restricted to orchestrating a set of worker nodes or pods, but the way Kubernetes ecosystem is growing is basically making it the universal control plane. It is going to orchestrate virtual machines. It's going to orchestrate, of course, containers. It's going to orchestrate microservices and some of the greenfield contemporary applications. But interestingly, Kubernetes will also orchestrate very traditional databases and applications. For example, SAP is creating an operator for SAP HANA, just like the Cassandra operator. And what does it really mean? You actually get a first-class citizen in the Kubernetes world, where you actually use some of the familiar tools like kubectl to orchestrate applications. It is not just about orchestrating infrastructure, it is about orchestrating applications. And that's going to blur the line between infrastructure and applications by bringing everything into the same level playing field. So you don't need to really look at the workload at the abstraction and the infrastructure as the bottommost layer. That is going to completely blur. And I think the Cassandra ecosystem will also evolve in this journey of making Kubernetes as a universal control plane.
Blurring the lines, Kathryn. Maybe we should end on that note, and maybe you could just provide us some illumination on what comes now for Cassandra from your perspective and what you're looking to release in some of the next versions of this new open source project that you're helping lead?
Sure. I think Cassandra is amazing at what it does, scale and replication. And what we've done with the Kubernetes partnership is made it much easier to love for operators. So the next thing that we need to do is make it much easier to love for developers. And then we'll bring a little bit of AI into the mix, and it's the ability to innovate is limitless from there.
It certainly is. And so I just want to thank all our panelists here to just say, hey, Sam, first, before I stop, I need to pass you back the syrup here, okay? Yeah, I don't want to keep this here at our house.
Yeah, stop bogarting the syrup, man. Okay,
yeah, there
thanks.
you go. There you go. So on that note, I just want to thank DataStax for sponsoring this virtual pancake breakfast. Thanks to all the people who did provide questions. We will be answering more questions through email. And so if we did not get the questions asked on today's broadcast, then we will then get back to you, through email and get those questions answered for you. Again, a big thanks to our speakers. And I just do want to say all our best to everybody out there. These are very difficult times, and we're really thinking how, the progress continues to be made and the conversation moves forward. So discussions like this are just so vitally important. So I just want to thank everyone here for their participation. I just do want to add that the new stack and DataStax will be providing a contribution to the question that we choose as the winner for this breakfast. And there will be a donation given in their name to the hospital or healthcare provider of their choice. I'm Alex Williams. I want to thank everyone for participating. We'll be back again soon.